Welcome back to week 1 discussion in our organic chemistry 1 course. Now we were talking about the 3 major families of carbon containing compounds. We talked about alkanes, alkenes and alkynes. Okay, let's start with alkanes first. Okay, now I'm going to start off with any compound that contains only carbon and hydrogen typically fall under any one of these families, but if they all contain only single bonds, okay, compounds that fall under the alkane family, alkane family typically have only single bonds. So, and they usually only have, for now we are going to restrict our attention to just carbon and hydrogens. We will see down the road that we will add other elements in the process, but for now I want you to understand the general formulae. For alkanes is, just remember this because we will probably come back and tie this formulae in the larger sequence. So keep in mind, and n right here is the n always refers to the number of, sorry, let me erase this right here and actually put it right here. N is the number of carbon atoms. Now keep in mind, in the second part where I wrote my hydrogen, I put the 2n plus 2 in brackets because students don't do the math right. So that is specifically the reason why I'm starting off in this particular format, and we're going to use this formulae quite a bit throughout the course. So it's not something, it's only going to appear on the screen. While I may not bring up each time, 3 months into the course I'm not going to write this, I would expect you remember that, but this is very, very important. All right, so let's go and create some compounds. All right, so we're still in the alkane discussion. So Cn H2n plus 2, right? And I said the n corresponds to the number of carbons, and we looked at CH4. Let's see if we got our math right. So there is only one carbon, so if you put it into this math right here, it will be C1H, H2 times 1 plus 2, well, there you go, CH4. Now that is very lame, but I just wanted to show you that if you have only one carbon, the most number of hydrogens you would have would be 4. It cannot be 3, it cannot be 5. Again, this ties into the idea of what I discussed earlier in terms of our general chemistry 1 and 2 in terms of the orbitals and valence electrons. Now let's say let's want to write a compound. Let's pick the next obvious, C2. How many hydrogens would I have? Well, C2, because it is, the reason we're doing this is because initially it's difficult for people to get around the idea unless I give them the whole formula. So hydrogen is 2 times 2, right, plus 2, which would be C2H6, right? So that means if you do the reverse mapping, we would have had 6 hydrogens, right? Now let's take this a step further and see how do we all have seen organic chemistry compounds and fascinated, or how do they draw and things like that. All right, carbon must always be connected directly to another carbon. Now keep the general structure I drove earlier. A carbon will have 4 bonds, right, and it's attached on 4 ends to something else, right? Now each carbon is only giving out one electron, okay, and whatever it's pairing with will generate the other electron and create a sequence of compounds. Chemists call this catenation. Okay, what is catenation? Means it's long chains. So the shampoo that you have probably has fatty acids in them that have chains that are longer than the Great Wall of China. Okay, so catenation is long chain. Okay, so what I'm saying here is, so if I were to do it for the C2H6, if this is the compound, okay, that means I have to, and I told you it's part of the alkane family. Now down the course I will give a compound, I will not tell you whether it's part of one of the three families and have you figure out does the compound have a single bond. But we're in the very initial stages, so let's not go there. All right, so we got two carbons. Carbon cannot be connected to another carbon only through an oxygen, but we're not there yet. We're only focusing only on carbon and hydrogen. So if your compound only contains carbon and hydrogen, only a carbon can be connected to another carbon. Okay, it cannot be connected through another element to another carbon. Does that make sense? So what I'm saying here is, since our compound has carbon and hydrogen, this is not a combination possible. Okay, carbon can only externally attach to other elements, but internally when it wants to attach to another carbon, it can only do so by directly attaching itself. Okay, so each carbon has shared one of its bond to make a single bond. That means each carbon now has 4 bonds, right? Okay, one of the bond is commonly shared between both of the carbons, okay, right? But each of these still have 3 more bonds. Every carbon at the end should have 4 bonds. Now this carbon has donated one of its electron and the other carbon has donated other one of its electron to make that bond. Again, bond can only be made with 2 electrons. That's what I was referring to. Okay, so if I get my blue color, I can take my point across. Okay, this carbon has donated its 1 electron and this carbon right here has donated its other electron. So let's get the red. Okay, so they've all used 1 out of the 4 electrons. That means they still all have that 1 odd electron sticking with them, and they can't just be left like that. So it needs to bind with something for it to happen. Something has to happen. So all of these. So now if you noticed, we have 6 loose ends and we have exactly 6 hydrogens, right? So we will put the hydrogens, okay, where the loose ends are. Okay, now let's go get our blue color. What the hydrogen has done is, hydrogen is 1a, means it can only donate 1 electron, and each hydrogen has donated 1 electron to pair with that odd electron from the carbon. Now we have our organic structure right here. You see that what we learned in general chemistry was not just for that class. It all makes sense when we apply that knowledge here, right? So I'm going to stop here and then have you create a few structures for me. Do it exactly the way I have done here. You have to first put the number of carbons in the formulae, figure out how many hydrogens you'll have, and then you will create the compound. All right, so I'm going to come back with a few more structures and have you write it. All right, stay tuned.